This one, question 6. Yeah, can you see it now? So here you have a male population with blood pressure that is normally distributed with mean, mu, and variance unknown. And we want to find a confidence interval for mu and variance. So if you want, so in this case, you want to find a confidence interval for both the population mean and the population variance. Okay. So I will give you about 10 minutes to do this question number 6. Then afterwards, I will show you how to do it. Hello guys, if you're just joining us, we are doing question number 6 from sheet 9, example sheet 9. You guys done? Had you done question 6, guys, or not yet? All right, let me show you how to do it. If you haven't done it, let me show you how to do question 6. Okay. All right. So this is question 6. Oh, sorry. Question 6. So here we are looking for a confidence interval, 98% confidence interval for both the population mean and population variance. And we are told that, the sample size n is equal to 30. And we are also told that the sample mean x bar is equal to 127.442, and the sample variance s squared is equal to 228.661. Right, and we are looking for 98% confidence interval. In other words, 100 times 1 minus alpha is 98, which implies that alpha must be 0.02. Is that right? Yeah, 0.02. Okay, so these are the stuff that we are given. All right, the first part is to find the CI for mu. So we want to find the CI, confidence interval for mu. And you should look at the 4 different formulas that I gave you at the beginning, right? the formula that applies to this situation is the second one, which is x bar plus or minus t n minus 1 is 29. 1 minus alpha by 2 is 1 minus alpha by 2 will be 0.99. All right, then S is what is given to us is square root of 228.661 and divided by n is 30. All right, so this is maybe, all right, okay, maybe I should have done it in a little bit more detail. So let me just erase this just a minute. All right, the formula, I mean, what I meant to say was that the formula is this one. What I meant to say that this is the formula, right, that is applicable to this situation. Right? When you're looking for the confidence interval for the mean or the population mean when the variance is unknown, right? So this formula will be, but for this particular situation, it will be 127.442 plus t n minus 1, which is 29, comma 1 minus alpha by 2 is 0.99. S is square root of 228.661 divided by the square root of 30, right? This is what you get. And this will be, if you read this from the normal table, sorry, not the table, the T table, I mean. So if you read this from the T table, you will get the following. You get 127.442 plus or minus 2.462 divided by the square root of 30. Okay, so this is the answer for the first part of question 6, right? Now for the second part of question 6, you're looking for the confidence interval for sigma squared, right? Which is, you remember the formula that I just gave you, right? Of the four formulas that I gave you, the one that is applicable to this one is this one. Right? This is the formula for the confidence interval for the population variance, right? Right, so this will become, our n is 30, so n minus 1 is 29, multiplied by s squared is, it's already given, is 228.661 divided by the chi squared 29. 1 minus alpha by 2 will be 0.99, okay, comma, same thing, 29 multiplied by 228.661 divided by chi squared 29, 0.01. All right. Now, a long time ago, I showed you how to read the tables of a chi-square distribution, right? So if you read the table for the chi-square distribution, you can read the two values in the bottom, and you will get the following. You will get 29 multiplied by 228.661 divided by 49.588, right? That's what you will get from the table. 29 times 228.661 divided by 14.256, right? Okay, so this is the confidence interval for the population variance. Okay, guys, are you okay with this or not? You have any questions on question number 6, which we just did? Just please use the chat box or use the microphone, whichever is easier for you. Oh, y is n minus 1 s squared, because that's the formula, sir. So you should just go back to the formula, sir. The formula that I just gave you at the beginning of the tutorial. Let me go back. Okay, these are the 4 different formulas. These are the 4 different formulas. I don't know, can you see them? These are the 4 formulas. These are the 4 formulas for the confidence interval. So the confidence interval for sigma squared is the lower limit is n minus 1 s squared divided by the chi-squared percentile. The upper limit is n minus 1 s squared divided by the chi-squared percentile. So these 4 formulas, I talked about them in the lectures before the lockdown. Before we had the lockdown, I talked about these 4 in the class, in the lecture halls, right? I think you must have a copy of them in the printed notes or the scan notes. Both of them should have copies of these 4 formulas, right? So please have a look at them, and so you need to know how to apply these 4 different formulas. Okay. So you don't need to know their derivations, but you will need to know how to apply them. That is exactly why I'm doing all these examples, Okay, guys, I hope that is clear. Apple, are you okay with that? Hello, you okay, sir? Okay, thank you, man. Thank you. All right, so the next question, the final question in the example sheet 9 is question 7. So can you have a go at example 7? Example 7 on example sheet 9. So let me close this and open the share screen. Share. Okay. Share. So this is example 7. I hope you can see it. All right. It's not difficult really. So can you try and see if you can do it? Guys, you okay? So you have a random sample from a normal population, so x1 to xn, and y is equal to ax plus b. So the first part is to show that this and that. Okay, so let me show you. So if you haven't done it, let me show you how to. It's not really difficult at all. So the first part is to show that. All right. So let's begin with question 7. All right. So you have y. Y is a new variable which is equal to ax plus b. Right. So we are doing part 1. Okay. So we want to find mu y. Mu y is the expected value of y, which is the expected value of ax plus b, which is equal to a times the expectation of x plus b, which is equal to a times mu x plus b. So that proves one of the first statement. The second statement is about the variance. So sigma y squared is the variance of y. Yeah, which is the variance of ax plus b. Now the variance of x plus b, I'm sure you know, is equal to a squared times the variance of x. Now, and this you can write as a squared times sigma x squared. So sigma x squared is the so we are done question 1. All right guys, are you okay with this? So this is the proof of the first part, the first statement, and this is the proof of the second statement, right? Okay. Now, part two is to show the same thing in terms of the sample values, right? Okay, is to show the same thing in terms of sample values. So here in part 2, we need to show that y bar is the mean of all the y's. So it's, in other words, it's the sum 1 over n times the sum of yi. Okay. Now we know that yi is axi plus b. So you can write this as a times xi plus b, right? Okay, now if you take the summation inside, you get 1 over n times a times the sum of xi plus the sum of b. Okay. Okay, now we know the sum of a constant is n times the constant, so this will become 1 over n times a times the sum of xi plus n times b. Okay. Now if you divide by n, you get a times 1 over n times the sum of xi. Okay, and b divided by n is b. and this is precisely equal to A. What you have here, is X bar, right, plus B. All right, so we've done the first statement, and the second statement is similar. All right, so this is the proof of the first statement. So let me put it in a red box. So this is the proof for the first statement. Okay, and the second statement is, okay, start with the sample variance for the y's, which is, I'm sure you know, is the definition. This is the definition for the, this is the definition for the sample variance of the y's. Okay, all right, and this you can write as 1 over n minus 1 yi is axi plus b. Yeah, y bar we just showed that is ax bar plus b, so minus of y bar is this. Okay, so now if you pull the a outside, this will become, these two guys cancel. As you can see, the b and the b cancel, right? So if you pull the a outside, it becomes a squared times this, right? Now, what you have here, guys, what you have here is the sample variance for the x's. So in other words, this is equal to a squared times s x squared. So we have proved also the second statement. So this here is the proof of the second statement. All right, guys, are you okay with this or no? If you have questions, please use the chat box. All right, so we've done part 2 of question 7. So the next one is part 3. If you look at part 3 of question 7, it's about confidence interval. So you're given a confidence interval for mu of x, which is from Lx to Ux. So you're given that Lx to Ux is a for mu x. That's what you're told, right? And which implies that the probability that mu x lies between Lx the probability that mu x lies between Lx and Ux is 1 minus alpha, right? That's the definition. I'm sure you know the definition of a confidence interval, right? So this is what the definition is. Now, what I'm going to do is I'm going to multiply everything within the brackets by a. Okay, and then I'm going to add a constant b to everything within the brackets. Okay. And then if you look at the question, right? If you look at the question, what you have here is what they call, welcome guys. What you have here is what is called LY, and what you have here is precisely mu y, and what you have here is uy. Okay, so we have shown. So what we have shown is that is the following, that the interval from Ly to uy is a 100 times 1 minus alpha percent ci for mu y. Right? Are you guys okay? Sorry, excuse me. Let me write this again. For mu y. Okay. So we have completed part 3. So this is the proof for part 3. Now part 4. Part 4 is the final part of question 7. Excuse me, sorry. This is the final part of question. You are given a confidence interval for sigma x squared. So what you're told is that the interval from Vx to Wx is a 100 times 1 minus alpha percent confidence interval for sigma x squared. All right, which means it is the same as saying that the probability that Vx less than or equal to sigma x squared less than or equal to Wx is equal to 100 times 1 minus alpha. Now, what I'm going to do here is I'm going to multiply everything within the brackets by a squared. So it will be a squared Vx less than or equal to a squared excuse me, sorry. A squared sigma x squared less than or equal to a squared Wx. It's equal to 1 minus alpha. Right? So you see what I've done. I have multiplied everything within the brackets. Now this guy here is what is called Vy. Okay. And this guy here, if you look at part 3 or part 2, this is precisely sigma y squared. And this one here is what is called Wy. Okay, so hence what we have shown is that the interval from Vy to Wy is a 100 times 1 minus alpha percent Ci for sigma y squared. Okay. So that completes the proof for part 4. All right, is this all clear to you? Or are you guys okay or no? Do you have any questions on this example? Sorry, question number 7, which is the last question on the example sheet. Hello, guys. Talk to me, guys. You okay? All right. It's good to know. Thank you. All right, guys. So I will see you. You should. I mean, you should have it as you know. You can email me 24/7 or Zoom me 24/7 for any questions you have. And tomorrow is Friday. Tomorrow we have an example class from 11 to 11 to noon. So if you want to attend that, that's fine with me too. But otherwise, keep well and stay away from all these problems on the coronavirus. So and take care of yourself. And any questions you guys have about the course or any other matter, just email me 24/7 or Zoom me 24/7. Okay, guys. So it's good talking to you, man. So I will talk to you again, guys, some other time. Okay. Yeah, you guys have a nice day too. Okay, thank you, guys. Mm.